Hey everyone, this is Cosets, and today we'll learn about what is a normal subgroup and Lagrange's theorem, important theorem. So in this today's session we will discuss what is a normal subgroup and we'll understand what is Lagrange's theorem, right? So first of all, let us understand what is a normal subgroup. A subgroup H of a group G is said to be a normal subgroup of G if what? This AH equals to HA. Now we all know what is this AH and HA. For every A belongs to G. This AH and HA, so that means these are the left cosets and these are the right cosets. So if we have a subgroup H of a group G, it is said to be a normal subgroup if the left cosets and right cosets, they are same. Okay. Now let us discuss example. So let H equals to this 0, 3 and find the left and right cosets of H in group Z6. This type of sum we already did in previous session, and determine whether H is a normal subgroup of Z6 or not. So for normal subgroup, what we need to find the left and right cosets, and if both are same, and we can conclude they are the normal subgroups. Now solution. So first, obviously, what we'll do, we'll prepare the table for Z6 and plus. Okay, Z6 and plus. So how to do that? As we have the Z6 or modulo 6. Okay, so this is the table. So here we have plus 6 and it is Z6. So the elements will be from 0 to 5. Total elements will be 6, but the elements start from 0 to 5. Fine. So here 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Now 0 plus 0. So that will be 0. How? 0 plus 0, and if we divide it by 6, so remainder will be 6. Now 0 plus 1, 1 divided by 6, remainder will be 1. So this row is clear. Now consider this 2 plus 4, so that is 6, and 6 divided by 6, so the remainder is 1. Now 2 plus 5, 7, 7 divided by 6, so the remainder is 1. Consider this 5 plus 3, so that is 8, 8 divided by 7, 8 divided by 6, so the remainder is 2. So this is how you can find the table. Okay. So left cosets of H. So AH will be, the notation is this: AH set of all A star H such that H belongs to H. It is the definition. Now see 0H. So what we'll do? So 0, as we have the left one. So here the left entries will be 0. So 0 modulo 6, and the elements, the set is given. The set is H is given, that is 0 and 3. Okay, so here it will be 0 and 3. Now 0 plus 0 divided by 6, so the remainder is 0. Now 0 plus 3 divided by 6, so it will be 3. So 0, 3. Now in same manner 1H. Now let us list out each and every one. So 3H, 4H, 5H, and yes, up to 5H. Now as you can see that we have 0, 1, 2, 3, 4, 5. So what will be the pattern? So the first, as we have the left coset, so the left two entries will be according to that. So 0, 1, 2, 3, 4, 5. In same manner, the second element, the left entries will be according to that, and the right entries will be what? The given set. So the 0 and 3. Now how to calculate? Suppose we have 3 plus 0 divided by 6, so the remainder is 3. Now 3 plus 3 divided by 6, so the remainder is 0. Consider here 5 plus 0 divided by 6, so the remainder is 5, and 5 plus 3 divided by 6, so 8 by 6, so the remainder is 2. So this is how you can calculate left cosets. Now in same manner the right cosets. So the definition will be like this, that HA equals to set of all H star A such that H belongs to H. Now instead of 0H, we'll write H0. So H0, now the pattern will be different. Now here the right entries will be 0, like this, 0 and 0. And the left entries will be 0 and 3. So 0 modulo 6, 0, 3 modulo 6, 0. So the answer will be 0, 3. Now let us list out each and every one. H5. So what will be the pattern? As you can see that we have the right cosets. So right entries will be according to this: 0, 1, 2, 3, 4, 5. So as you can see that the right entry for each and every element, 0, 1, 2, 3, 4, 5, here 0, 1, 2, 3, 4, 5, and the left entry will be the set itself. So the entries of the set itself. So 0, 0, 0, and here we have 3. Now how to calculate it? So consider this 0 plus 2 divided by 6. So remainder is 2. Now 3 plus 2 divided by 6. So remainder is 5. Now consider this 0 plus 4 divided by 6. So 4, and 3 plus 4 divided by 6. So 7. 7 divided by 6. So the remainder is 1. So this is how you can find the right cosets. Now as you can see that all the left cosets and right cosets are same, that 0 3 0 3 1 4 1 4 4 1 4 1 5 2 5 2. So here 0h and h0, 1h and h1, up to 5h and h5. So all are same. So just by the definition of a normal subgroup, it is a normal subgroup of Z6 because the left cosets and right cosets are same. Okay, now let us discuss note. See, if G is an abelian group, then every subgroup of H of G, it is a normal subgroup of G. Again, if G is an abelian group, then every subgroup of H, it is a normal subgroup of G. I think we discussed this at result in previous 1 or 2 sessions, that if it is an abelian group, then left and right cosets are same. So actually it is the result of this. Fine. So if we have abelian group, then every subgroup H of G, it is a normal subgroup of G. Okay, now let us discuss Lagrange's theorem. So the statement is, the order of each subgroup of a finite group, it is the divisor of order of the group. Again, the order of each subgroup of a finite group, it divides or is a divisor of the order of the group. So for that is, order of H divides order of G. H is a subgroup and this is a group. So the subgroup's order divides the main group's order, right? Let us discuss example. So let G equals to 1, minus 1, I and minus I be a multiplicative group, and H as a subgroup 1 minus 1 be a subgroup of G, right? So here order of G, so that means how many elements are there? That is 4. And order of H, how many elements are there? So there are 2. So it is very obvious that order of G divided by order of H, so that is 4 by 2 equals to 2. So that means this order of H divides order of G, which is what? The total number of distinct right or left coset of H in G. So it is a simple statement that order of each subgroup of a finite group divides the group, the order of the group, right? So this is Lagrange's theorem. Thank you.